Hello, greetings to everyone, and welcome to La Lumiere Bilingual School Complex. Today, in this tutorial, we are going to be looking at a topic in Class 6 Mathematics or Senior Primary School Mathematics, and the topic is sets and logic. I am going to be explaining everything in this tutorial of today based on the scope of what we are going to be doing for today, and then I'm going to leave you with an assignment which you will have to do, and then you're going to do it in your exercise books, and then we are going to do the correction in school. All right, for the sake of self-presentation, I am Sir GODWILL YAKUM. For any details, you can message me or you can call me through this number that has been displayed on your screen now. All right, communicating the theme, the driving theme of the academic year 2023-2024. It's the theme is digitalization of instructional processes or educational processes and the reinforcement of moral and citizenship values for the transformation of basic education. So now we are going to go by e-learning, and we are going to be digitalizing our studies this evening. All right, to begin with, like I said, we are going to be looking at this topic, sets and logic. In La Lumiere, the motto of our school is discipline, responsibility, success. So we need to be very disciplined when watching this video, or get to a place where it is quiet, a very quiet environment, with your mathematics book, exercise book, and your pen. Follow the video, you write down everything that I'll be saying that are important, you write them down, and then at the end I'll leave an assignment which you will have to do. So you copy the assignment as well and you do it. All right, to begin with, like I said, we're going to be looking at the topic set and logic, or the set theory. Now, what is the meaning of a set? When you hear set, what first comes to your mind? So what is a set? A set is a collection of items that have something in common. Now, the items that make up a set are called elements. So in a set we have items, and those items are called elements, and a set is a collection of items that have something in common. So when we group items that have something in common, we can actually name it a set. Now let's look at some examples. The first example we have here is the set of numbers. For example, these are numbers here. So now in the set of numbers, the elements of the set are numbers. For example, we have 1, 2, 3, 4, 5, 6, right up to 12, and the 3 dots at the end indicate that the set actually continues. It does not end at 12, so it continues, and the last element is not present here. All right, let's look at another example on set. Another example of set of fruits. For example, we have mango, orange, pear, banana, grapes, and so on. Set of heavenly bodies. We have, for example, stars, moon, sun, satellites, and so on. Set of kitchen utensils. We have pots, knife, frying pan, blender, cooking spoon, and so on. Set of even numbers. We have 2, 4, right up to 20, and so on. It continues. Then now we have set of prime numbers. For example, set of Cameroon ministers. We have Laurence Serge Etundingwa, we have Navola Leonga Pauline, and so on. Okay, now set of animals in the forest. For example, we have lion, tiger, elephant, and so on. So these are examples of sets. These are a collection of items that have something in common. Each of these sets have something in common, so we can group them together and call it a set. So these are some examples of set, and we're going to dive into the first part of our tutorial today, we're going to be talking about the element of a set. So a set actually has, like we said, element, the entries of a set, or the different items, the different items that make up a set. We call them elements of a set. So now we use the symbol element of and not an element of. So this symbol represents element of, and this one represent not an element of. Now let's look at some examples. This helps us to be able to illustrate whether or not an item is an element of a set, or using this symbol element of. Right, let's consider the set of prime numbers, for example. Now we have this displayed on your screen. Now let's check that 2 is an element of the set A, where A is the set of prime numbers. 2 is an element. Why? Because we can find 2 in the set A. So since 2 is an item in A, we can conclude that 2 is an element. So when you see this sign, you need to know that it's an element. Now let's check 3. Since we can find 3 here, 3 is an element of A. 13. Since we can find 13 in A, 13 is equally an element of A. Now let's check for 18. 14. Now in this whole set of A, we cannot find any item there that is 14. Therefore 14 is not an element of A, and equally 15 is not an element of A, because we cannot find 15 all through the set A. Now let's look at finite and infinite set. What are finite set and what are infinite set? A set can be finite or infinite. A finite set has the following characteristics. Number 1, a finite set has an exact number of elements. An exact number of elements. There exists a last element, and then for example, the set of even numbers less than 10. Set of even numbers less than 10 is a finite set. Why is it a finite set? We can list the elements of this set: 2, 4, 6, 8. These are even numbers less than 10. So now the elements of this set, we have 1, 2, 3, 4. There are 4 elements. So it has an exact number of elements, which is 4. We have 4 elements, and then there is a last element, and the last element here is the last digit, which is 8. So we can conclude that this is an example of a finite set. Let's look at infinite set. What is an infinite set? An infinite set has a continuous number of elements, so it has no end. It does not have a last element. Now it ends with 3 dots, and the 3 dots indicate that the set actually continues. So it indicates that the set is continuous. Now example, let's take the set of numbers. The set of numbers, for example, 1, 2, 3, 4, and so on. Notice if you are counting this, if you are counting 1, 2, 3, these digits or numbers, if you are counting numbers from 1 till infinity, then you may spend the whole of your life counting numbers from morning till evening, till the next morning, till the next evening. You will not finish. You reach 100, 1,000, 1,000,000, and so on, and you will not actually get to the end. So there is no end, or there is no last element when it comes to the set of numbers. So the set of numbers don't have a last element. It ends with a 3 dots. So the set of numbers is an example of an infinite set. Any set that does not have an exact number of elements or does not have an end is infinite. Alright, now let's talk about an empty set. This is a set that has no element. The set is actually empty and there is nothing inside. So it can be denoted as such with this sign or this sign. So if you see any set that has this sign there, you should be able to know that it is an empty set. Either this one or this one is a representation of empty sets. Okay, now let's look at some examples. Let's consider a set of months of the year that have 32 days. Now we know very well that there is no month in the year that have 32 days. So it is an example of an empty set. Had it been we have months with 30 days, September is an example. But now there is no month that has 32 days. So it is empty. If you are taking that set, the set will actually have no element. So that is why it will be empty. Another example, now let's consider the two sets below. Set A and set B. Set A 1, 3, 5, 7, 9 and set B 2, 4, 6, 8. Set A and set B. Now let's take the set A intersection B. We notice that A intersection B is going to be an empty set because there is no element here that is also here. So A intersection B, the set A intersection B is an empty set, for example. Alright, the last thing we're going to be talking about is disjoint sets. What are disjoint sets? If two sets A and B exist, then now these two sets A and B are said to be disjoint if and only if A intersection B is an empty set, or A intersection B is empty. So if you are to verify that a set is a disjoint or two sets are disjoints, then you must verify the intersection of those two sets to make sure that it will give you an empty set. In case it gives you an empty set, then the sets are disjoints. So we have like disjointed sets. Now let's look at the example. Let's consider the sets below. Set A and set B. Now we know that A intersection B means elements that are found in set A and they are also found in set B. But when you check, 1 is here, is not here, 3 is here, is not here, 2 is here, is not here. So finally, there is no element in set A that is also found in set B. So the set A intersection B is empty. There is nothing there. It's an empty set. Alright, so hence, since A intersection B is empty, we can conclude that A and B are disjoints, or they are disjointed sets. So I hope we now have a clear understanding of what disjoint sets are. Alright, like I said, I'm going to leave you with an assignment. This is your homework that you're going to do. It's going to have two questions. This is question 1. Consider the following sets: A 1, 3, 5, 7, 9, B 2, 4, 6, 8, 10. Find A intersection B, the complement of set A prime. Then you find A prime intersection B, you find A union B. And then now question 5 says set A and B are disjoints, yes or no. So in question 5 you just answer with yes or no, giving a reason why your answer is yes or no. If set A and B are disjoint, then you say yes. If set A and set B are not disjoints, then you say no. Alright, question 2. Question 2 says Alima was born. That's the A part of question 2. Question 2A. Alima was born on the 12th of March 2013. How old will she be on the 12th of March 2023? 2 marks. B. Consider the figure below. We have a figure like this. So this is the figure. There's a dot here, and then this is allocated 7 centimeters and 7 centimeters. So now, what is the name of this shape? Roman 2. Name any heavenly body that has this shape. What is a heavenly body? A heavenly body is actually a structure that is found in the atmosphere, in space, or that is found in the sky. So now you name any structure in the sky that has this shape, the shape of this thing. There are so many, you just name any one. Okay, you find the area of the figure. Find the circumference of the shape. And to be able to solve these questions well, I have provided you with some important formulas. Area is given by pi radius squared, and circumference is 2 pi radius, where pi is numerically equal to 22/7. So here we come to the end of this lesson today. Make sure you do this assignment. Actually, you bring it to school tomorrow.